Now I'd like to show you a fun and productive way to create an inspection routine from a CAD model. In this lower right hand corner we have the Cad Navigator. This is the Cad Navigator module in the Gage X software. And from the Cad Navigator we'll pull in the CAD model, identify what portions of it or features on the part that we want to have the system measure, and then have it generate that inspection routine for us. So the first step is pulling in the CAD model. Let's do that. In this little sample part that we saw here at the beginning of the presentation, we call it the fast start. It's a sample demonstration part. The manual has several example exercises in it, and the CAD model is provided with the system. So this is something that you can try even before you have your own samples to measure. Let's open that. And as we do that, we walk through a little wizard that guides us through the process of identifying which features we want. Now maybe we only want to, here's the full CAD model as it came in. Perhaps we're only interested in this bolt hole pattern, for example. So if we want to get rid of or delete out different sections that we're not interested in, we can run around and highlight these features and delete them, or we can use the box tool to highlight them and delete them. Let's see here. This will allow us to do this one, delete that, delete that. Maybe we'll leave in some of these other things as well. This. Why don't we leave in this slot as well? So those are the features that we're actually going to inspect, and then we have different ways of establishing datums or part setups with fixtures or not. And the next part of the wizard asks us to identify which features on the CAD model we're going to use as our datums. So in this case, I'm going to highlight this circle down here and then 0 my X, Y, Z on that one, and I'm going to highlight this here and tell it to align the X-axis through that hole there. The last portion of it deals with our measuring our datums, I should say. So let's do that. We'll say finished, and now the system's going to walk us through the portion of the datum alignment that we've done. Now in the CAD model here we can see several features. We talked about the blue box being the area of the field of view, which is what we see over here in the live image. While we're generating CAD, there's a type of what you might call follow the bouncing ball guidance, and that is you'll see two different triangles here, a green one and a yellow one. The green one is where we're currently located. It's the center of the blue box in this case, and the yellow one is where the system wants us to drive the stage. Now this is a manually driven system, so we have to be the motors by turning the cranks on the system. Also, as we go over here, let's bring your eyes over to the live field of view image. As the destination triangle comes into the field of view, we can see that the destination is highlighted here in the field of view as a circle, and where we're currently located is highlighted as a blue plus sign. And what the system is guiding us to do is overlay the blue plus sign into the circle, and when it does, it happened quickly, but it fired off the edge detector, the feature finder target, and it measured that circle. Let's come back over here. I zoomed in on this, so we've lost that. I'll keep it full scale now so that we can see what we're doing. It indexed our destination triangle over to this feature. So now as we move that triangle, the green one moving closer to the blue, and now we get again inside the field of view. We can see We're going to overlay here in the live image the blue plus sign inside the red circle, and it fires off the edge detection as soon as it registers that it's there. And then we've successfully established our datums inside the program. Now if we come over here to this enhanced editor section, we can see this is the program that's been created so far. A circle followed by an origin in the X, Y, and Z axes, and then another circle followed by an axis alignment of the x-axis. Okay, that's the beginning of our inspection routine. Next, we can specify various different amount of coverage. If we want to measure 100% of data points around a feature or just a small section of it, this can affect how extensive the program is that is created. That's dealt with here on this screen. We can also ask the system to create the program either in the order it was drawn, the CAD order, or into a more optimized order, which is just the nearest feature next to where we're currently located. Let's ask the system to simulate what it would do if we just did a nearest feature optimized path here. I'll click on the test path button, and we'll see what the path would be of the program execution. This is blue box moving around is the order that the program will be generated in. Let's try that one more time. All right, that looks good. Let's go ahead and generate those steps. There's a Generate Steps button in the bottom right-hand corner. And now that's built the program, and we're ready to run it. There's another feature here of the of this CAD Navigator system, and it's very much like an optical comparator with an overlay chart. Right after we've registered the part to the CAD model by measuring the datums, we have the ability to push this button here, which is called CAD, and that provides an overlay template here on the live image. Now, I don't know if you can see this because of the imaging, the lighting right now. I'm going to turn out the backlight that we have on, and you can see that pink circle. What that pink circle is it's an overlay of the CAD model onto the part. So as we turn up the lighting and are imaging the actual part, we can see that there's a mismatch between where the CAD model says the part should be and the actual feature that's here in the part. If we move up to a different location, you can see on this slot, for example, oops, turned the light the wrong way. Here's our CAD model representation, and this is how it overlays onto the part. So not enough material on this side, not enough material on this side, so the slot is a little bit wider than expected, and this radius doesn't fit very well either. So this can be used very much like an optical comparator. In fact, if you were to create a special CAD model instead of like what this one is a CAD model showing the nominal dimension of the part. If we were to create another CAD model showing a maximum and minimum boundary around each feature, then when we did this and imaged the part, we could see if the edge of the part fit between those two boundaries, indicating a passed part, or if it fell outside the boundary, indicating a failed part. All right. Well, we've created this program, and that's the section on Cad Navigator. We'll have another little segment here that shows us the execution of that program. Now we're ready to execute the program we just created with the Cad Navigator. Here's a text representation of that program in the enhanced editor. In order to run that program, well, let's first give it a name. And we'll call this one Demo 1. In order to run the program, we click on the Run Routine button, which is just looks like a play button. And then we can look at the model here to guide us. Again, the blue box tells us where we are as we move our stage around. And the origin of the part is located here with these arrows. So this Run Measurement Routine window comes up, and when we're ready to execute the program, we accept that with OK. And now it walks us through. Again, it uses the yellow destination triangle saying where we should go, with the green being where we currently are located. So let's move the knobs on the stage here and travel over to what we're interested in measuring. And then again, in the field of view, we see the circle, which is our destination, and the blue, which is our current location. We overlay those, and it fires off the edge detection to find that hole. And when we come up to the second location over here, position it, fires that off, and it asks us to step up to this slot, and we overlay these guys here, measures an edge, and it guides us up to the next higher section of the edge of the slot, and it measures that one. That's guiding us to the end of the slot, measures that, and working down the other side of the slot here, following the bouncing ball, so to speak. Now, lighting is also controlled by the program, and if there was a lighting change or a magnification change in our program, the system would do that automatically. The only thing that's not automated is the positioning of the stage itself, which I'm doing manually with the control knobs. So here we have this circle, and now it moves us up to the next one, and so forth through the program as we've created it here. Let's see. There's another. It's guiding us down to the center hole. Right, and the next section of the center, and up to the top. And we're getting close to done here. The features we asked for. I don't know if you're able to pick it up with the resolution of the camera, but these holes that we're measuring are very rough. They have burrs and or contamination in them, and I don't know if you can tell, but the feature finder is handling those extremely well and provides one of the strengths of the system in terms of the system's ability to deal with part variation and still get the correct edge. This is something that is better explored in a in-person demo so that you can see the details of it. Okay, so there was our measurement routine, and we've accepted that. It's executed it. It's filled in all of the blanks here. Now we have no printed report for that yet. Everything that we've measured is remembered and stored in the system, and any of that could be highlighted for a report. For example, if we needed to know the diameter of this circle right here, we could either click on it here and then go in and check the checkbox for the diameter and accept that, and then our output appears down in this location. Or we could use the text editor and come in here. Let's go to their different views. This is a condensed view, and maybe we wanted the diameter of this circle here. You can click on it in the text view, expand it, and then also print the radius or diameter of that. In this case, we may also want to add a tolerance here, plus or minus something, and we may want to put a comment on it so that it makes more sense in our output. This is dimension number 2. Get rid of that equals sign in front of it. That was a typo. All right, that looks fine. So let's do that, and that's added it to our output stream. Over here we have a very standard output. This first one we labeled as dimension number 2, nominals, actual measured values, tolerances, deviation from the nominal, and whether or not we're in or out of tolerance. There is a whole range of outputs that we can talk about beyond the scope of this presentation, but we'd be happy to show that to you in the future. Thank you for spending the time with us for this brief overview presentation of the RAM Optical Starlite GX and Gage X software.